Today we will learn how fiber and field-proven 5G mmWave fixed wireless can coexist together. We'll explain how 5G can leverage your fiber network and bridge the gap of old and costly DSL infrastructure. If you have questions, please text us via the system. We will address them at the end. Today's presenter will be Boris Meisel, Ciclus Head of Business Development. With that, I will hand the presentation now to Boris. Let's begin.
Yeah, thank you, Danny. Thank you to all attendees. We have a pretty big forum here, so I'm glad um, to start the session. And sorry for a slight delay, as we've seen some people joining us. Hope you can hear the audio. The audio is coming through, and the slides are okay, and we're good to go. So we are going to talk today. The 5G is all over the place, and you're probably familiar with the term. But this webinar is going to be on very practical aspects, and I'm going to talk a lot about numbers, to talk a lot about problems that you guys are dealing with, and to give you some tools, and hopefully it will be very fruitful for you to attend. So the agenda for today is we'll start from the latest and actually not so greatest about what's going on with the wireline carriers here, in particular in the United States. And the main problem, as we'll see, is the churn. The customers are leaving wireline carriers, and the answer, what is the answer to that? And we propose that the answer to that, at least at the technical side, is hybrid fiber wireless approach. We'll talk about that. We'll show some numbers. We'll show some topologies. We'll talk about the connectivity unicorn. So where this multi-gigabit opportunity lands today, we'll talk about that, and we'll end up with talking about practical examples on how to onboard thousands of gigabit customers, even if you're a small service provider, still providing gigabit capacity that is kind of the standard today. Okay, so I plan to have this session to have the slides for about 20, 25, maybe 30 minutes. And later on, we'll get to the Q&A session. You can post your questions here using the platform. We'll try to answer as many questions as we can during the session. If not, you can reach out to me. My contact details are here, and of course the session will be recorded and will be added to the Ciclus site, and we'll distribute the slides and the recording at the end of the session today. So we'll start from a brief review of the main facts about the wireline carriers. As you can see here, these are the number of subscribers, and actually, or the number of additional new subscribers. And actually what you can see here is that wireline carriers, in particular small one, the red one indicates the Frontier, and Windstream and CenturyLink, they are losing carriers. Quarter after quarter, you can see that this trend continues. It started last year, and it continues for 5 or maybe even 6 quarters in a row. And the churn is big, and in particular, small carriers suffer from that. And what we are going to talk today is how to stop that, or how to provide a solution to that. And we are going to talk about how fiber and the millimeter wave coexist, and this is the hybrid fiber hybrid fiber wireless approach. So if you look into the pure fiber deployments here in the United States, you can see that the number of fiber subscribers is growing, and these two graphs represent homes marketed as home passed, and homes connected. A year ago, there were about 13.7 million of homes connected, and the pace of the homes are being connected here in the United States are about, you can see, about a million homes per year. We have roughly about 100 million homes here, so it will take us additional 90 years to connect all the homes. The other thing that you can see here is the actual gap that is growing between the home passed and home connected. Number of home passed is growing year over year, or at the pace that our home being passed is growing year over year, while the pace at which the homes are connected stays still. And the conclusion from that is that the core, or the fiber core technology, is fast and furious, but the drop is still suffers. So the drop connection, the last mile, the last hop connection, is slow and costly. So what we are going to talk today about is how to solve this last hop problem, and what we propose is a combination of fiber and millimeter wave wireless. So how does it work? The fiber, we are not fighting fiber, and there is no way that wireless technology can kind of replace fiber, but it is kind of complementary, and in some cases it is enablement technology to the fiber. So the fiber should be there. There is no other way to provide gigabit or multi-gigabit capacity without having fiber backbone. Though when you go to densification, when you go to the distribution of this fiber to the access, probably the last mile fiber is not the best solution because of the time to market and because of the cost. So what we propose is to combine the core fiber with millimeter wave wireless as an access solution. There are several topologies or several use cases where how this wireless can complement this fiber. In some cases, it is just pure access. So this home here is lit by fiber, and it provides wireless connectivity additional to the neighboring homes. Or the wireless technology can also be an aggregation technology, and aggregate several other radios or several other links. It can connect homes. It can connect street furniture like poles or bus stops, etc., to provide connectivity to Wi-Fi or to camera devices. And even it can provide connectivity to the single-family homes. We'll talk about that in the next couple of slides. Now, it's not a new technology, and as you can see here, this is a snapshot of San Francisco. You can see that virtually in 4 years, the number of radios that are registered here in San Francisco area grew from 0 to several thousand, and just during the last year, there were 1,000 links registered in this area. The network is dense, so this technology is widely used, is widely adopted. We have several carriers here in the United States, and particularly here in San Francisco, that use this technology for access to extend their existing fiber. And if you look into this deployment, so there are about 3,000 links registered here in this area. Can it be done without fiber? The answer is no. to feed this network, to feed this gigabit, multi-gigabit capacity network, there should be fiber POPs, and it should be connected to the fiber. Can it be done with fiber only? Probably the answer is no, because of the speed of deployment, of the cost of that. So this illustrates how this technology is scalable and how it is widely adopted. So it's not something new, it's something that is being used. The business case is proven, the technology is proven, and I'll show you several use cases with some numbers here later on. But I assume that you know what fiber is, and now let's talk a bit about the millimeter wave. So millimeter wave, I'll tell you a small anecdote about that. I participated in a conference in Las Vegas, Wispapalooza. It was last year, not this one, not this year, 2016. And the conference, it ended later in the evening, and I had an early flight, 6 a.m. From Vegas to San Jose, and I took an Uber from the airport. And so the Uber driver, he was chatty, sometimes they speak, and so we are at 6 a.m. In the morning in Las Vegas, and he started the conversation with me. He asked, "What do you do? What did you do in Vegas?" I said, "I participated in a conference." "What conference was that?" And I said, "Well, it's about connectivity. It's about internet." And he says, "Well, there is a new thing in the internet. There's a new thing in the connectivity." And at that point, I became curious, and I said, "What is that?" And he says, "It is millimeter wave." So Vegas, 6 a.m., Uber driver talks to me about millimeter wave. So millimeter wave is all over the news, and with regards to the 5G mainly. So let's understand what the millimeter wave technology is, what the millimeter wave wireless is. So we are, Siklu, we are developing equipment in mainly two bands. In V band, which is the 60 gigahertz, it is unlicensed band, and E band, which is 70-80 gigahertz, which is a lightly licensed band. So we'll start from the V band. V band, which is called the 60 gigahertz band, it spans from 57 gigahertz up to 71 gigahertz. So this block of spectrum contains about 14 gigahertz of unlicensed spectrum, which is more than all other spectrums, all other bands put together. Wide spectrum or a lot of spectrum means a lot of capacity. So this is first key property of the millimeter wave frequency, that due to the large spectrum that is available in these bands are capable of providing gigabit or multi-gigabit capacity. So this is about V band. In E band, we have just 10 gigahertz of unlicensed, of lightly licensed band. Lightly licensed band, it means that there is a registration process of $75 per 10 years, which is really negligible. The license cost is really negligible, but you get all the benefits of the protection. So if someone else wants to deploy additional radio at the same location, at the same direction that you already deployed the radio and registered the radio within FCC database, you get the protection. So the other person needs to switch channel or switch polarization, depends on how dense the deployment is. So, but the first property of this spectrum, of those bands, is that there is huge amount of capacity available, a huge amount of spectrum available, and it means that they can deliver gigabit or multi-gigabit capacity. Now, the other property is that as you go up with the frequency, the antenna beams become very narrow. And the propagation, actually, the free space loss increases, so the propagation of the radio frequencies becomes shorter, and it means that those frequencies, the antennas are very directional, and the energy is not spread all over, like in sub-6 bands, but it's very directional and it's very focused. It is called the pencil beams. So the benefit or the advantage of that is that those frequencies are virtually immune to interference. So the first property we've talked about, high capacity, and the second property of this frequency is immunity to interference. Another advantage or another thing that actually improves the immunity or adds to the immunity of interference, that there are a lot of non-overlapping channels. For example, in V-band there are 20 non-overlapping channels, and all those properties enables high capacity and dense deployment of the equipment that operates in those millimeter wave frequency, as we've shown in the previous slide, as you've seen in San Francisco. Okay, another thing, as I've mentioned, you've seen the San Francisco deployment. Now, millimeter wave is a field proven and widely deployed technology here in the States, in other countries as well. According to the registration numbers or the FCC database is publicly available, so there is no, it's not a market research, it's not kind of analyst data. You can download the data and do the analysis by yourself. But according to the data that is available in the FCC, there is 75% of year-over-year growth in the number of links registered in the United States. And basically, we see two main use cases or two main verticals for our solutions. One is smart city, safe city, which I'm not going to address today, and the other one is broadband. And with regards to the smart city, we today directly involved with more than 80 cities in the United States. They use millimeter wave for the smart city applications, for cameras, for sensors, for Wi-Fi, for muni Wi-Fi, for small cell, etc. So all in all, it is widely adopted, and worldwide, this is the fastest growing wireless technology, as may seen from different reports, and this is actually what we see from our business. Now, for for kind of where the technology is heading, or what is the potential of this technology, Facebook announced during their last F8 conference, they also experimenting with those frequencies, as they believe that this is the next generation of the connectivity technology because of the properties that we've discussed earlier. And they have managed to get 36 gigabit per second for an E-band point-to-point link. So this is kind of where this technology is heading. Today, we deliver systems between 1 and 10 gigabit per second capacity, but as I've mentioned, there is a huge amount of spectrum, and the capacity that can be achieved using this technology is probably much more than commercially available links today. Now, it is being adopted by, as you can see, some of the carriers and some of the companies that use this technology. Webpass from Google Fiber, Verizon, Facebook is experimenting with that. AT&T announced their plans in the millimeter wave. Different police departments, operators all across the globe. So this is something that is happening, and this technology is being deployed and being used by all over the globe. Now, so we've seen the challenge of the telecom industry. We've seen we've reviewed the hybrid fiber wireless approach that can address this challenge. Now, where is the opportunity, or where the be precise, we're at the multi-billion dollar opportunity here, and it is MDUs. So if you look at the numbers here in the United States, the number of multi-dwelling units in terms of the structures, it's about 1.5% out of let's say 100 million different structures that we have. 1.5% are the MDUs. But in terms of the customers, in terms of the broadband customers, this 1% is responsible for almost 20% of broadband customers. So attracting or targeting this segment is can grow your customer base significantly. And if we do the math, so this is where the numbers are coming from. So the number of structures of MDUs that are 5 or more units is 1.5 million here in the United States at the monthly fee of $70 per gigabit connection, and the average number of customers per MDU of 16, and adoption rate. If we do the math, it results in more than $8 billion target addressable market. And the good thing is that it is addressable by big carriers, but it also can be addressable using millimeter wave technology by small service providers as well. So how does it work? For the small service provider, just to give you a sense of the numbers, if you do 5 MDUs per week, it results in 260 MDUs per year, with 50 tenants at 40% take rate. It is about 20 customers per MDU. It is 5,200 new gigabit customers and about 5 million, assuming $70 per gigabit connection, about $5 million of new revenues. This is one of the examples we've designed together with the service provider that we work with. As you can see, this is a downtown area, and we had 86 buildings here in the downtown area. And based on the line of sight data, we've designed this network. As you can see here, it's kind of a mesh network, but it's actually rings and sub-rings. It means that there is no single point of failure, and this network is redundant, as you can see, wireless can do rings as well, not just fiber. And it gives the operator, because everything is connected, so now the operator can optimize his fiber decisions. If he wants to bring fiber, and he needs to bring fiber to feed this network, you know, having this network, having the full topology in mind, he can now decide where is the best place to put the fiber to. Probably those junctions that feed several rings, one here and maybe one here or one here, are the best locations, though he can decide that he put the fiber here, and using our networking features and the quality of service mechanism, this capacity can be distributed. And this is, for example, this location, to bring fiber to this location may be faster or cheaper than bringing it to the heart of the downtown area. So having this wireless network design before doing fiber decisions can actually enable or optimize the fiber routes of the operator. So all in all, we connected here 86 buildings as I've mentioned, in ring mesh topology. The typical distance here in this project is less than 1 mile. It means that the availability of this design is at least 4 nines. And the business case that we've done is about $6,400 per building connected, including the labor, including the equipment, and about $340 per unit connected. And this includes in-building connectivity, assuming $70 and assuming service offering and other assumptions that the service provider gave us here, the ROI here is 6 months for this project. Another example is so-called garden-style apartments or complexes or business park or plazas, where the apartment is actually composed of several smaller buildings. So the main building is connected with fiber or with the E-band radio where the fiber is not available. The second building block in this solution is point-to-multipoint radio that can distribute the connection from this main building to other buildings or to common areas like pole here to provide Wi-Fi at the common areas or to connect cameras at the parking lots. And then inside those buildings, additional in-building connectivity technology can be deployed like Gigabit or Ethernet or Wi-Fi to provide connectivity to the end user. So in this design, assuming the assumptions here we had for this particular complex, apartment path is just this portion without in-building connectivity. The apartment path is $80 per apartment, and the apartment connected is $420, and the ROI here is 8 months. I'll be glad to have a detailed session with you if you have any questions about the business case. And to sum up the technology or the solution building blocks here is that the backhaul, as I've mentioned, is fiber, where fiber is available, or E-band point-to-point radio that can handle up to 10 gig for distances up to 3 miles. The drop is implemented using point-to-multipoint V-band, in which a sector can handle up to 1.8 gigabit per second. And in-building connectivity is fulfilled by either Gigabit or Ethernet or Wi-Fi. So this is kind of another example of residential MDU connectivity using a combination of fiber, millimeter wave, and other technologies. Suburban or single-family homes, neighborhood. So in this case, we had an operator that he had an access to, he had fiber pop at the data center. So this fiber pop was extended using E-band radio to the neighborhood, and then kind of mesh point-to-point topology was implemented inside the neighborhood to provide connectivity to the homes. And the business case is that home connected is about $800 ROI of 8 months. And some additional pictures from the installation and from deployment by other operators. As you can see, the point-to-multipoint radio, very easy to install. The screwdriver is all that is needed, and it illustrates how simple residential deployment can be. All the cables are standard cables, everything is Ethernet, and just within 5 minutes, everything is up and running, and the speedless results are hundreds of megabits to the end user. A couple of words about Ciclo. As I've mentioned, we are focused on the millimeter wave, and we are the leading company, the leading equipment vendor in the millimeter wave field, with more than 50,000 installations in more than 30 countries. The United States is our biggest market, and we have complete millimeter wave solution to address all those applications that we've talked about, and some more with regards to smart city, safe city that we didn't cover in this webinar session. As we mentioned at the beginning, E-band spectrum, E-band frequency is lightly licensed. It means that there is a registration process. So every radio that is installed should be registered within FCC database. In 2015, and it is publicly available data, so it's not research, it's not analyst report, it's just plain data from the regulator. In 2015, we had out of all radios, 45% were Ciclo, And 2016, almost 60% of registered radios in the United States were cyclo-made. So it means 2 out of 3 radios that were installed here in the United States are cyclo-made. We target in the broadband aspect. We serve, or our equipment is designed to serve MDUs, MTUs, garden-style single-family homes, and this is what we have in our portfolio. On the left-hand side, this is E-band radio. So E-band radio is more suitable for rooftop or tower connectivity because of its form factor. So you can see here, this is one foot antenna. We have 2 feet antenna as well. Different connector, different interfaces. Everything is Ethernet, but we have a combination of fiber and copper. Different power supply options, PoE or NEC 48, which is standard telco voltage. In the middle, we have a point-to-point V-band radio, and this radio is designed for street-level connectivity, mainly for those smart city, safe city projects to connect cameras, to be installed at the poles, to connect Wi-Fi, to connect small cells. So this is 6 by 6 inches box, really, really small, with all the networking features, with all the bells and whistles of carrier Ethernet, with different flexible options to configure this radio. It also has a PoE in and PoE out to power up the radio, to power up additional devices that are placed at the pole. And this one can provide up to 1 gig aggregated capacity at about 0.6 range. And this one here is the new point-to-multipoint radio. It is a sector here. The sector is also really small, 7 by 5 inches, really thin. And it can provide up to 1.8 gigabit of aggregated capacity for up to 8 clients. And the main application is single-family homes or smart city application as well. Another part of our offering is the planning capabilities. So we have planning tool that is going to be released next month. It can help actually to automate all the network planning and deployment process. You can add location of the poles. You can add locations of the buildings, of the units that you'd like to connect. The tool will generate the topology. The tool will generate the bill of material. It will do it will generate configuration files. It will also do RF planning, and so you'll be sure that the network performs and delivers the gigabit capacity that you'd like. It also can take into account line of sight LiDAR data to do line of sight analysis. And this is from what we see, this is one of the most important enablers for the mass deployment, for the automation of the planning and the deployment process. So just to sum up, and we'll be open to the questions. Hybrid fiber, we'll talk about hybrid fiber wireless is about enabling and monetizing existing fiber. So the millimeter wave wireless actually complements and leverages the existing fiber network and provides the densification solution or the densification part in this topology. We have a very broad millimeter wave portfolio that enables gigabit connectivity to virtually all broadband scenarios, MDUs of all sizes, complexes, business plazas, and even single-family homes. So the advantage of this portfolio is that you can adapt the right solution, the right radio to serve your needs and to make the business case work. And V-band and E-band are easily accessible spectrum that actually doesn't require big investments like Verizon or AT&T did for licensed 5G bands. And actually, it can provide the same fiber-like connectivity if the network is planned correctly, and without any investment in the spectrum asset. So it can deliver gigabit capacity. It can go to a mile, 2 miles, and even more than that with the proper equipment and with the right antenna. And you don't need to have any lengthy registration process. You have a location, you can serve it today. So this is all on my side, and I see that we have a lot of questions. So Benny.
Yes, Boris, we do have. We're going to work very hard on it. Second, I'll bring it up. So the first question is how millimeter wave is related to 5G?
Yeah. So 5G 5G relies on high capacity, low latency, and the millimeter wave frequencies can supply both. So 5G can operate in different frequencies, but really, in order to get to the gigabit capacity, it should take advantage of it will take advantage of the millimeter wave. And when FCC opened additional bands in last summer, they claimed that the millimeter wave frequency will be part of the 5G, and this is what is this is due to the physical properties of this band, lack of interference, and and uh, and capability to achieve gigabit or multi-gigabit speed. Now, yeah, now maybe another note. 5G is kind of a more marketing term, and from what I see in the real deployment of 5G or real implementation of 5G is that there is a mobility part of 5G which takes care of mobile users, which is really challenging, and um, it is something that will probably not happen soon. The standard is still not there, but there is the fixed wireless part of the 5G that is already happening. And probably the fixed wireless part, this is the first step that will be implemented by the carriers. And this is something that will help them to bridge the gap from the core fiber that they have to the end user. And this is exactly what we are talking about. So fixed wireless, it is fixed wireless access 5G is pretty much what we've talked about today.
Okay, thanks a lot, Boris. Next question is what is the difference between millimeter wave bands, the V-band 60, E-band 7080, and the other bands that we hear about 28 and 39 gigahertz?
Right. So it's a good question. V-band and E-band are considered to be V-band is unlicensed band, so you can use it, and it has 14 gigahertz of available spectrum. E-band is lightly licensed, so you get the protection of the of the license frequency, though you don't need to pay huge amounts for the spectrum and for the link registration. So the license to operate the link in E-band is actually link by link, so you don't need to acquire chunk of spectrum like in other licensed bands. Uh, um, it still has 10 gigahertz of available spectrum, and it deliver gigabit or multi-gigabit capacities. Other millimeter wave frequencies like 28 and 39, these are licensed millimeter wave bands. And in order to operate equipment, you need to purchase a license to those bands, and some licenses are going to be going to are within the FCC today. So there will be an auction. So those licenses will be auctioned. Some of the licenses were held by several companies, and you've heard about StraightPath, where Verizon overbid, paid billions of dollars to get access to those frequency bands. So you need to. It is actually in putting it into practical terms. Those licensed millimeter wave bands, 28, 39, those frequencies are virtually not available to smaller service providers because they need to pay an arm and a leg to get access to those frequencies. By the way, 28 is mostly controlled by Verizon. 55% of those frequencies controlled by Verizon. So it makes it even more difficult for smaller service providers to get access to this frequency. Additional thing is that in V-band and E-band, the ecosystem, the components ecosystems are pretty much established because it's not really a new technology, and it means that vendors like us can do low cost or cost efficient devices that can make the businesses work for those MDU, garden style, and even single family homes use cases. There is not such ecosystem available as of today for 28 and 39. So the ecosystem there is evolving, but it will take several years to the chip vendors to come up with the components, and to OEM, to system vendors to come up with the systems that will be cost efficient enough to serve those fixed wireless access use cases.
Voice?
Yeah.
The next question: how complex is the process to get a license for the 78 giga license part, license plan?
Yeah, so the process of getting a license for the E-band is pretty simple. Everything is online. You need to provide coordinates of the link of both sides, and you get a license. Everything is online. You pay the fee online, and within 1 day you get your license to operate the frequency, to operate the link. There is no license procedure in the V-band because it is unlicensed band.
Okay. What other applications are utilizing today millimeter wave?
So we've talked today about broadband applications like MDU connectivity, complexes, business connectivity to provide the internet access to the buildings, to the businesses, and to single-family homes. Additional applications are mobile backhaul, so provide connectivity to macro sites. And now, with all those unlimited plans proposed by the carriers today, they really suffer from the backhaul capacity. So one of the solutions is to utilize E-band because it can boost their capacity comparing to traditional microwave with an order of magnitude. Other applications are smart cities. So, in fact, smart cities is the fastest growing market today, and millimeter wave is one of the enablers, because as we've seen in the San Francisco picture, the network can be very, very dense, and this is actually the sweet spot of millimeter wave. So the density, the capacity. So the city's dense urban environment is the sweet spot of the millimeter wave. Usually those projects begin with safe city connecting cameras, but once the infrastructure is in place, additional sensors, additional devices are being added. Another application is these line replacements to bypass old and costly DSL lines. So this is something that is also being used by carriers. I think these are the major ones.
Okay, boys, thank you. The next question is what are the main advantages of licensed millimeter wave versus the traditional unlicensed sub-6 gigahertz frequencies such as Wi-Fi?
Right. So the main advantage of the millimeter wave frequencies over sub-6 bands is actually two. One is capacity, that you can actually guarantee gigabit SLA to the end user, because once you deploy the radio and you actually you plan the network right and you have line of sight. Millimeter wave is a line of sight technology. So once you have a line of sight from point A to point B, you can guarantee the performance. So it's uh, uh, predicted performance that you calculate and you can charge for, because this is a gigabit performance that you can actually guarantee under SLA. And so actually, in fact, that there is kind of two main advantages: guaranteed performance without interference, no matter how dense the deployment is, and the other one is capability of delivering gigabit or multi-gigabit capacities. And this is because of the nature of the spectrum, because of this physical characteristic of this band, of the amount of spectrum that is available there, that is actually 20 times more than in sub-6 bands. The antennas are 10 times more narrow. You have 10 times channels are 10 times wider. So kind of, if you combine all those factors, you get to those gigabit performance and interference-free scalable deployments.
Okay, thank you, boys. We have more. Stay tuned, please. How much training is required to become a millimeter wave equipment installer?
Right. So I'll make a distinction between the V band and the E band. E-band radios are, as I mentioned, are very narrow, so it is 1 degree or less, and you need to at least watch a SQL video on how to install the antenna. And we put a lot of hooks and a lot of smart technology into our radios in order to simplify the installation, the alignment process. So we have dedicated alignment modes in which it is much easier to install our units comparing to competition. But all in all, for event radios, some training is required, and but it doesn't require to be kind of traditional microwave or classic microwave installer. Uh, every person that has some expertise with or experience with microwave or millimeter wave after watching a training video is capable of installing E-band links. With the V-band, the story is much simpler. For the point-to-point, the distances are shorter. The antennas are a bit wider, so the installation is really simple. And the point-to-multipoint actually doesn't require an installation at all, because it has beam steering capabilities, and Really, it is Wi-Fi, so-called. We like to call it Wi-Fi, Wi-Fi-like installation, because you just need to point it in a general direction and connect cables, and that's it. So the point to multipoint really doesn't require any skills from the installer.
Okay. One before the end, how the radios are managed and provisioned.
Right. So this is also an important question. We have different provisioning and different management protocols that are supported. So the basic ones are the CLI using SSH or WebGUI. We also support SNMP. We also support DHCP for zero touch. We support different user level protocols like TACACS and radios. We support 802.1x for authentication. So multiple protocols and multiple schemes are supported. We have the same software release that actually covers or supports all our radios. So once the integration is made into the existing management system, it is very easy to maintain and to add radios. Each and every software is supplied with the MIB file, so it's pretty straightforward.
Okay, thanks. And let's see the last one. Yes. What technologies are used for in-building connectivity?
Well, there are some use cases, mainly for venues, kind of things for the for our point to multipoint solutions. Hopefully, we'll release some case studies on that toward the end of the year, once we have deployed some of those radios. Uh, but yes, in general, it can be done, in particular in convention centers or large venues, to provide connectivity to. Once again, if you, I mean, when I work at the conferences, in particular in big ones, the Wi-Fi coverage is pretty bad, and the cellular coverage depends on the venue, how DAS deployment is good there. But all in all, the connectivity experience during those big events is pretty awful. So we have some projects where our equipment is where the V-band point to multipoint equipment is brought in to provide dedicated gigabit connection to some to some use case, to some customers, and it's not, frankly, it's not something that is big. We just started to test the water there, but hopefully we'll be able to share with you some of the use cases and success stories toward the end of the year.
Okay, so with that, I think we ended answering all those questions. And I think it's time to say thank you to all our participants for staying with us during this webinar. And stay connected with us with our email blast and with our newsletter. And feel free to call us or send Boris an email to find out how you can bring Gigabit to your network.
Okay, thank you guys, thank you very much for your time. The session will be available, the recorded session will be available, as well as the slides in our site. We'll send an email to all the participants. Don't hesitate to reach out to me with any question you have. You have my email in the first slide. I'll put it here, and it's boris.m@ciclo.com. So once again, thank you, and we'll be glad to support you in your mmWave journey.